Welcome, algebra class, to another amazing episode of Mr. Chow Time. This time we're talking about literal equations and dimensional analysis. This is lesson 15. So, when we're solving for equations, we're often solving for a variable. And when we solve for a specific variable, that means that we're solving for one of the variables in an equation. So here's the formula for the speed of a wave, where v is the speed of the wave, f is the frequency, and lambda is the wavelength. That's just an example of a formula in which we solve for v, the speed of the wave. So here's another example. Let's say we have this equation, 15 equals 3n plus 6p, and we want to solve for the variable n. So we want to isolate n by itself. The first thing we can do is we can subtract 6p from both sides. So 15 minus 6p equals 3n. Then we can divide by 3, right? And so that would be 3 divided by this on top, and we'd have to distribute that 3. Just like if we were to multiply both sides by 3, we would have to distribute for division as well. So 3 divided by 15 is 5, and 3 divided by negative 6 is negative 2p. And so now we've solved this equation for the variable n. So I'd like for you to solve this for the variable k. All right, welcome back. To get the k by itself, the first thing I would do is multiply both sides by 5. So now we have 55j equals k minus 2. Then we would just add the 2 to both sides. Now we have k equals 55j plus 2. We've solved for k. Okay. I'd like you to do this one now. A times the sum of q minus 8 equals 23. We're solving for q, so we want to isolate q. We can divide both sides by a. Q minus 8 equals 23 over a. Actually, I should probably add a little thing here just to differentiate the a from the q, otherwise they look kind of similar. And then we want to add the 8 to both sides, so q equals 23 over a plus 8. And there we have it. We've done it twice now. Moving on. So let's say we're solving for a variable in a formula. The formula for the speed of a wave is, again, v equals f times lambda, where v is the speed of the wave, f is the frequency, and lambda is the wavelength. So if we solve for f, v equals, can you hear Riley in the background? I hope so. If we're solving for f, then we want to divide both sides by lambda. And so the frequency of a wave is the speed of the wave divided by the wavelength. That's how you get the frequency. So let's solve for x here. Now we have 3 different variables. So we want to solve for x, which means we would want to get this x over to this side and everything else out of there. So yeah, the first thing that you can do here is just divide by, is that the first thing you want to do? Yeah, sure, we can divide both sides by z. So that would give you 3x over z minus 2y over z. All right, I'm back. Sorry, I had to go deal with Riley. Yeah, I don't know where I was. So I'm just going to start over. 3x minus 2y equals xz plus 5. Okay, I don't know what I just did, but I'm going to do something different. I'm going to add 2y to both sides so that 3x equals xz plus 2y. Then I'm going to subtract xz from both sides to get 3x minus xz equals 2y plus 5. Then I can reverse distribute the x out of this to get 3 minus z equals 2y plus 5. And then I can divide both sides by 3 minus z to get x equals 2y plus 5 over 3 minus z. Okay. So that's how I would have done that one. Why don't you go ahead and do this one? Okay. So we can subtract 5c and 3d to both sides to get negative 2d equals negative 5c minus 1. And then divide both sides by negative 2, and d equals 5 over 2c plus 1/2. All right. Go ahead and do this one next. 6q minus 18 equals qr plus t for q. So we could subtract qr from both sides. So 6q minus qr minus 18 equals t. We could add 18 to both sides. 6q minus qr equals t plus 18. We could reverse distribute the q out of this to get q times 6 minus r equals t plus 18. Then divide both sides by 6 minus r, to get q equals t plus 18 over 6 minus r. Now, all the stuff that I'm writing, this is what I would hope to be seeing in your notebooks, by the way. When you're doing these problems, try not to do the problem on a different piece of paper, or if you do it on a different piece of paper, don't worry about transcribing it onto one paper where all the answers are together. Because remember, I'm not really interested in the answers. So if you're doing the work on a piece of paper, you might as well just be doing it in your notebook and just turning that in. Just so you know. All right, a literal equation. This is what this lesson is about. Well, it's an equation that involves several variables. So we've been looking at these equations this entire time. So an example of a literal equation, this formula, b equals 703 times the quotient of w over h squared, is a formula to compute someone's body mass index. Body mass index is also commonly called BMI, where B represents the BMI, W is the person's weight in pounds, and H represents the person's height in inches. So we're going to solve this formula for W. So what can we do here? Well, we can say that this is 703W over h squared equals the BMI, right? Which means we could multiply both sides by h squared. Oh, that was horrible. And we get BH squared equals 703W. Then divide both sides by 703. You get BH squared over 703 equals W, which is the weight in pounds. Oh, I wish I hadn't just erased that. Okay, so that was BH squared over 703, right, equals W. What is the weight of a person who is 64 inches tall, so 64 squared, and has a BMI of 21.45 over 703? Where's the trusty calculator? All right. 64 squared is 4,096. Multiply that by 21.45. And that equals 87,859.2 over 703. So divide by 703, and we get 124.98. So the weight of a person who is 64 inches tall and has a BMI of 21.45 is 124.98 pounds. Here's another example. Ohm's law states that the current in amperes, is equal to the volts over the resistance in ohms. So we're going to solve the formula for R. So again, we have current equals volts over resistance. We want to solve for R. So we can, so first we want to get the R out of the denominator. So we're going to multiply by R, and we'll get Ri equals V. Then we'll divide by I, and that'll give us R equals V over I. Then we're going to find the resistance of a circuit with 22 volts and 0.5 amps. So the resistance is 44 ohms, right? I just multiplied both the top and the bottom by 2 so that I can get that unit rate. This is over 1 now. Great. Dimensional analysis is the process of carrying units through a computation. I would give you an example of this, but I think we can just look at the next slide. A 10K run is 10 kilometers long. If 1 meter is 1.094 yards and 1 mile is 1,760 yards, use dimensional analysis to find the length of the race in miles. So we have a 10-kilometer run, and we want to get to an answer in miles, right? So what do we have to do to get there? Well, just like in multiplying fractions, for example, 5 over 2 times 2 over 3, we can cross these out, right? And we're left with nothing, basically. Well, not nothing, but we're multiplying by 1, which is the identity. Then we get 5 over 3. We can do the same thing with dimensions. So if we want to get rid of these kilometers, we can multiply by kilometers on the bottom. But if we multiply this and we want to get the same distance but in a different form, we have to multiply by 1, right? Just like if we had 5 over 2 and we want to get a different way of looking at this, we can multiply both the top and the bottom by 2 to get 10 over 4. And now we have a different form, but it's the same value, right? And we can do this with dimensional analysis as well. So if we want to get out of kilometers, we can multiply by kilometers on the bottom, but in order for it to be the same, the top has to be the same, right? So what would make it the same? Well, 1,000 meters is equal to 1 kilometer, right? 1,000 meters over 1 kilometer is the same as saying 1. If we multiply this, nothing is actually changed. We've just changed our units now to meters. But meters doesn't help us, right? We need to get to miles. And we know that 1 meter is equal to 1.094 yards. So we can multiply again by meters and yards. So 1 meter is equal to 1.094 yards. And now we're almost to miles, right? We could now multiply, where does it say it? 1 mile equals 1760 yards. So 1760 yards is equal to 1 mile. Now our kilometers have canceled out, our meters have canceled out, our yards have canceled out, and all we have left is miles. So 10 times 1,000 times 1.094 is 10940 miles over 1 times 1, and this is a 1 here, 1 times 1 times 1 times 1760. Then we need to convert this. You could convert this into a mixed fraction if you would like, but I'm going to convert it to a decimal because it's easier on a calculator to do that. So that gives you 6.215 miles. So a 10K race is basically a 6.215 mile race. Okay, I'd like for you to do this one on your own. Welcome back. A car travels a distance of 100 feet in about 2.8 seconds. What is the speed of the car in miles per hour? So we would like to get to the point we have miles and hours, right? So the first thing we can do is exchange the feet. And actually, I'm going to move this over a little bit. I think I need a little bit more space than this. And I might be writing a little bit smaller as well. Okay. 100 feet over 2.8 seconds. So, so the first thing you might need to do is go to Google and find out that 5,280 feet is equal to 1 mile. So we would first do that conversion. We want miles on top, so we want feet on the bottom. 50 to 80 and 1. So that takes care of our feet, but we're still in seconds, so we need to convert this to hours, right? So how many seconds in a minute? 60 seconds in a minute. And then we need to convert our minutes to hours, right? So we put minutes on top, hours on the bottom, 60 minutes in 1 hour. Oh, look at all the space I have. So now we're left with our miles and hours. 100 times 60 times 60, that's 3,600, and then 2 more zeros, 3,600, and then 2 more zeros, that's 360,000. And then, oh boy, all right. 5280 times 2.8 equals 14,784. I4s always do that. Is there a way, I wonder, to get the computer to stop recognizing that I'm not taking my thing off the... Anyway, okay. Miles and hours. But see, the question asks, what is the speed of the car in miles per hour? And this per indicates that we're talking about 1. So we need to then multiply this by 14. Oh, it's done it again. Why would you do that? I clearly don't want to connect the top of my 4. 14,784. Sorry, I meant to say divide here. Divide both by 14,784. Those are both 4s. Because dividing by 1 is the same thing as it being itself. If we divide both the top and the bottom by 14,784, then the bottom then becomes 1. And then, let's see, 360,000 divided by 14,784 is 24.35 miles per hour. And there you have it. Thank you very much. Have a good day.